Welcome to Engadget Tomorrow. I'm Imran Sheikh, and this is where you get to hear about tomorrow today. Today we're talking about water-soluble circuit boards and NASA's pick to build the nuclear rocket that'll take us to Mars. Let's kick it off with the thing that could cut carbon footprints by 60%. German semiconductor maker Infineon Technologies AG announced that it's producing a printed circuit board, or PCB, that dissolves in water. Sourced from UK startup Jiva Materials, the plant-based Soluboard could provide a new avenue for the tech industry to reduce e-waste as companies scramble to meet climate goals by 2030. Jiva's biodegradable PCB is made from natural fibers and a halogen-free polymer with a much lower carbon footprint than traditional boards made with fiberglass composites. A 2022 study by the University of Washington College of Engineering and Microsoft Research saw the team create an earth-friendly mouse using a Soluboard PCB as its core. The researchers found that the Soluboard dissolved in hot water in under 6 minutes, but it can take several hours to break down at room temperature. In addition to dissolving the PCB fibers, the process makes it easier to retrieve the valuable metals attached to it. UW assistant professor Vikram Iyer, who worked on the mouse project, said after it dissolves, we're left with the chips and circuit traces which we can filter out. Jonathan Swanston, CEO and co-founder of Jiva Materials, says adopting a water-based recycling process could lead to higher yields in the recovery of valuable metals. The board has a 60% smaller carbon footprint than traditional PCBs. Specifically, it can save 10.5 kilograms of carbon and 620 grams of plastic per square meter of PCB. Infineon has produced 3 different circuit board prototypes using the Soluboard framework. The company is currently only using the dissolvable PCB for demo and evaluation boards, and it says around 500 units are now in use. However, it's exploring the possibility of using the material for all boards with an eye on expanding adoption over the next few years. Based on the results of stress tests, it also plans to provide guidance on the reuse and recycling of power semiconductors removed from Soluboards to lessen the chances of the salvageable parts from future production models going to waste. Speaking of future production, let's talk about who will be making NASA a rocket to take us to Mars. NASA and DARPA have chosen aerospace and defense company Lockheed Martin to develop a spacecraft with a nuclear thermal rocket engine. Announced in January, the initiative, in which BWX Technologies will provide the reactor and fuel, is dubbed the Demonstration Rocket for Agile Cislunar Operations, DRACO. The agencies aim to showcase the tech no later than 2027 with an eye toward future Mars missions. Nuclear thermal propulsion, or NTP, has several advantages over chemically propelled rockets. First, it's 2 to 5 times more efficient, allowing ships to travel faster and farther with greater agility. In addition, its reduced propellant needs leave more room on the spaceship for storing scientific equipment and other essentials. It also provides more options for abort scenarios, as the nuclear engines make it easier to alter the ship's trajectory for a quicker-than-expected return trip. These factors combine to make NTP, perhaps, the ideal Mars travel method. Kirk Shireman, the VP of Lunar Exploration Campaigns for Lockheed Martin, said these more powerful and efficient nuclear thermal propulsion systems can provide faster transit times between destinations. Reducing transit time is vital for human missions to Mars to limit a crew's exposure to radiation. Since this is not the best medium for visuals, I'll describe the craft. It looks kind of like a white upside-down flashlight. The NTP system will use a nuclear reactor to heat hydrogen propellant rapidly to extremely high temperatures. That gas is funneled through the engine's nozzle, creating the ship's thrust. BWX said, this nuclear thermal propulsion system is designed to be extremely safe and reliable, using high-assay, low-enriched uranium, or HALO, fuel to rapidly heat a supercold gas, such as liquid hydrogen. As the gas is heated, it expands quickly and creates thrust to move the spacecraft more efficiently than typical chemical combustion engines. To help quell concerns about radioactive leaks in the Earth's atmosphere, NASA and DARPA plan not to power up the reactor until the ship has reached a nuclear-safe orbit where any tragedies would occur outside the zone where it would affect Earth. The agencies aim for a nuclear spacecraft demonstration by 2027, launched from a conventional rocket until it reaches an appropriate location above low Earth orbit. Nuclear reactors will also likely play a key role in powering future Martian habitats, with NASA testing small and portable versions of the tech as far back as 2018. Before NTP propels the first humans to Mars, it could find use on much shorter flights, as nuclear-powered spacecraft could also make transporting material to the moon more efficient. Shireman also said a safe, reusable nuclear tug spacecraft would revolutionize cislunar operations. With more speed, agility, and maneuverability, nuclear thermal propulsion also has many national security applications for cislunar space. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributor Will Shanklin and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.